Guys, in this specific video, we're going to look at additional terminologies which are going to be used in the concept of algebra. And of course, I've talked about the concept of terms in algebra. So therefore, we're going to have what we call like and like terms. And in this particular case, whenever we talk about the concept of like terms, these are going to be the terms which are going to have the same literal factors. I'd say that the literal factors are going to constitute the letters which are going to accompany specific representations of this algebraic expression. Now, in this specific case, then therefore, if I have x as a literal factor and they are the same, then therefore we're going to say that the 3x plus 10x are going to constitute like terms. Now, if contrary to that, if I have another expression which is going to be given as 3x and then 10x to the square of this, so the x and the square of that one is going to be different. Now, since that we can see this just a literal symbol that has been given, and this is the power of a literal symbol. So due to that variation in the power, then therefore this is not going to be a term similar to that one, and therefore this is going to constitute a like term, while these ones, the two, are going to constitute what we call the like terms respectively. So in this particular case, then therefore we can be able to differentiate between the like and like terms whenever you come across algebraic expressions. And then we're going to look at the concept of an exponent. Now, if I give an example of t to the power n, and now from the study of exponential functions, we had said that we can be able to give the meaning to this specific letter for t, and we refer to this one as the base, while this one is referred to as the power respectively. Now, the base and the power are going to constitute an exponent, and therefore we're going to see that we can be able to express an exponent in this specific format or notation by giving this one as a base to the power of this specific case. So for instance, I've just given an example of this. This is going to be an exponential expression of the base of 10 and the base of 10, or rather this is just what we refer to as a numerical coefficient, and this is going to be the base and this is going to be the power given as such. So therefore we can be able to express algebraic expressions in terms of exponent. And then I'm going to mention about the concept of algebraic expressions which are going to constitute of a number of terms. Now, the first case I had given an expression, so I can be able to give an expression of 10x squared, and then I can be able to give 10x squared plus y, and then I can be able to give an expression of perhaps 10x plus y minus 2 given as such. So if we try to look at this, this is going to constitute of a single term, and then therefore it's going to be referred to as an algebraic expression with only one term is going to be referred to as a monomial. So I can be able to just give this one for the exponent. So this is going to be referred to as a monomial. This is a monomial. And then for the expression with two or more two terms specifically, this is going to be referred to as what's referred to as a binomial. And then an expression with three or more terms is going to be referred to as a polynomial. And in this particular case, of course, I'm going to just be specific on this because perhaps I can just give specific examples to avoid confusion due to this particular aspect of a degree of course, that specific expression. So therefore, for a monomial, I'm going to have an example of one. So this is an expression with a single term. Can be given as an example of this 2x, and then we have an expression with the two terms, which is a binomial. And of course, for the binomial, I can be able to give an example of 2x minus 3y. As you can see, this one is a first degree expression, which I'm trying to create contrast from the first, of course, example I've given. And then we're going to have a polynomial. Now, in this case, for a polynomial, we're going to see expressions which are going to constitute, of course, some cases of a second degree expression. For instance, the square of a plus ab plus b squared, which is going to be given as an example of a polynomial. So in this particular case, we're going to see that for polynomials, the exponents are going to be expressed in positive integers, and of course, this is going to be expressed especially when we're going to deal with the concept of polynomials and operations. So in this particular case as well, we can be able to look at fractions. So algebraic expressions can be given in terms of fractions. So for instance, if I have the square of c over m plus 1 perhaps raised to power r. So this one is going to give perhaps a meaning of a particular relationship that is going to exist between different variables or maybe a particular phenomena. But giving it in terms of a fraction, and therefore is going to be a quotient over two algebraic expressions. Or for instance, I can be able to give a 1 over f. This is going to be an algebraic fraction given in this specific format. And then lastly, apart from the monomial, binomial, and the polynomial, and the algebraic fractions, we can be able to look at some of the signs and symbols which are going to be, of course, employed in dealing with algebra. So these are going to constitute a grouping, of course, grouping or signs of a grouping, which are the, we're going to have the parentheses, which are going to be given in that specific order, and then we're going to have what we refer to as braces, of course, which are going to be also given in that specific format, and then we can be able to have what we refer to as brackets. So the brackets are also going to be used in algebra, which are going to be given in this specific symbol, and then you can use a vincular. And this is going to be a bar that is going to be indicated on top of perhaps I can just give examples of these grouping symbols in a quick note so that we can be able to just conclude on that. So for instance, I'm going to have a plus b, and this is going to constitute what we call a parenthesis. So therefore we can as well have a process which are going to be a plus b, and then we are going to have 3 plus given as such. So this is going to be using of the brackets, square brackets given as such. And of course we can be able to use a vinculum using perhaps 3 plus b given using that bar note over there. So that is going to constitute part of the terminologies that we're going to come across in algebra and these operations and other related topics. So catch us in our next videos. We're going to look at the last bit of this specific aspect of essentials of algebra, and that's going to form a comprehensive part of the terminologies that we have already discussed and the one that we're going to discuss thereafter. So that is it for now, guys. Bye, God bless you.